So in this segment, we are going to solve a few questions based on similarity. Let us look at the first question. E is a point on side AD produced. So AD has been extended till the point E of a parallelogram ABCD. So ABCD is a parallelogram, which means that the opposite sides are parallel. And BE, so when I join the points B and E, BE intersects CD at F. So this is the point F. Prove that triangles ABE and CFB are similar. So now we have to consider these two triangles for similarity. Let us quickly separate out these two triangles. So I have drawn these two triangles separately. You will again notice that I have kept the orientation of the triangles exactly as what it was there in the original diagram. Now let's see what parts are equal. So first of all, AB and CD are parallel lines, right? So let us mark these two parallel lines. AB and CD are parallel lines, and I can consider BE as the transversal. So if I consider BE as the transversal, I know that according to alternate interior angles, angle ABF, that is this particular angle, the angle that is shown here, should be equal to angle CFB because of alternate interior angles. So there is a Z that gets formed, and we know that when a Z gets formed, you have alternate interior angles. So angle CFB should be equal to angle ABE. So these two angles are equal to each other. And secondly, we also know that the sides AE and BC are parallel. So AE and BC are parallel to each other. And now consider EB as the transversal again. So we again have EB as a transversal. Now you will notice that these two angles, angle AEB and angle CBF, are also equal to each other, again because of alternate interior angle. So it means this particular angle is equal to angle CBF, and therefore you notice that we have two pairs of angles that are equal. So one pair of angle is AEB and CBF, and that was because of alternate interior angles. So let's mark them. And the other pair that was equal was angle CFB and angle ABE. So by AA test, we can prove that these two triangles are similar. So let me start with the statements. So I can say that ABCD is a parallelogram. And because it is a parallelogram, I know that AB is parallel to CD. And also consider BE as the transversal. BE as the transversal. So you can say that angle ABF or angle ABE is equal to angle CFB because these are alternate interior angles. Alternate interior angles. And the lines are parallel. And the lines are parallel. Similarly, so the way we had gone ahead with the thought process, I am writing the proof in the similar order. So we had first proved that these angles marked with the green color are equal. So I have written that statement. And also I know that angle AEB is equal to angle CBF Again, because these are alternate interior angles, and I know that AD or AE is parallel to BC, and I can again consider BE as the transverse. Right, and now I have shown that these two angles are equal to each other. So let's mark these with results 1 and 2. And now I can start with my statements for similarity. So I will say consider triangle ABE and triangle CFB for similarity. So angle ABE is equal to angle ABE is the green angle, that is equal to angle CFB, because these are the alternate interior angles. And similarly, angle AEB is equal to angle CBF. I think instead of writing alternate interior angles, I have already shown that they are alternate interior angles. So I can just say from 1 and from 2. And therefore, triangle ABE is similar to triangle. So A corresponds to C, then B corresponds to F, and then E corresponds to B by the AA test. So this is how we were able to prove this particular problem. Again, just taking a careful look at the parallel lines and applying the properties of parallel angles or of parallel lines, I was able to prove similarity in this particular problem using the AA test. So I will again pause for a few seconds before moving on to the next question. Moving on to the next question. So consider the following question. It's given that OA divided by OC. So it's given that OA divided by OC is equal to OD divided by OB, right? So the ratio of these two sides is given as equal, and we want to prove that angle A is equal to angle C and angle D is equal to angle B. This is what we have to prove. So again, over here, because the ratio of two sides is given and because the angle in between is equal, because this is the vertically opposite angle, I can therefore say that maybe using the Sas test for similarity is possible. So I will go ahead and say consider triangle AOD and triangle BOC for similarity. And I can say that it's given that AO divided by OC is equal to OD divided by OB. This is given to us. So basically the ratio of the first side to the first side of this triangle is equal to the ratio of second side and second side of this triangle. And also I know that angle AOD is equal to angle BOC. because these are vertically opposite angles. These are vertically opposite angles, and therefore I can say that triangle AOD is similar to triangle. So now let's see the corresponding vertices. O corresponds to O in both the triangles. So let us place it at the center. From O, if I walk towards A, then that is going to correspond to walking towards C from O. So A corresponds to C. So A is the first letter and C is the first letter. And then you have COP over here. This is by the SAS test for similarity. And because SAS test has proven similarity, now I can say that angle A is going to be equal to angle C, because corresponding angles of similar triangles, and I can also say that angle D is equal to angle B, again because of the same reason, and hence proved. So this is how we have shown that the two angles were equal. Again, when you notice that the ratio of two sides is equal, ratio of two pairs of sides is equal, then SAS test is definitely a valid candidate to prove similarity, which happened in this particular problem. So again, let me pause for a few seconds before moving on. Okay, moving on to the next one. Let's consider the following problem. In the given figure, AB is equal to AC. So because AB is equal to AC, it's an isosceles triangle, and therefore the base angles are going to be equal. So I can say that it's given that AB is equal to AC, and AD is perpendicular to BC. So that is highlighted by this 90-degree angle. So let's shade it quickly. And also EF is perpendicular to AC. So let's shade that 90-degree also. And now we have to prove that triangle ABD is similar to triangle ECF. So let us go ahead and draw these two triangles separately. So now consider these two triangles. I know that they both have 90-degree in them, right? And I am now falling short of the second measure to prove similarity. So SSS is ruled out as a valid candidate for similarity because the sides are not known. So obviously the ratio is not known. SAS is also going to be difficult because the side lengths are not known. So maybe AA test is one valid test for similarity that I can use here. I am falling short of that second angle. I don't even have a common angle over here. But because triangle ABC is isosceles, I can say that this angle, that is angle B here, is going to be equal to angle C, because these are the base angles of the isosceles triangle, right? So these two triangles are going to be equal to each other, and I can mark those on the diagram here. So angle B and angle C, these two angles are going to be equal to each other because these are the base angles of that isosceles triangle ABC. And therefore, I can now use the AA test for similarity. So let's go ahead and complete the proof. I can say that since AB is equal to AC, this implies angle ABC is equal to angle ACB. And what is the reason for this? These are the base angles of an isosceles triangle. And therefore, I can now consider these two triangles. So consider triangle EFC and triangle ABD for similarity. I can say that angle EFC is equal to angle ADB, which is equal to 90 degree, because this is already given in the question. The lines are perpendicular. And also angle ABD is equal to angle ECF, and this is because of the result 1, right? So we have labeled the first conclusion as result 1, and that is what we are referring to in this particular statement. And therefore, triangle EFC is similar to triangle. Let us now look at the corresponding parts. F is 90 and D is also 90. Then C corresponds to B. So C corresponds to B. And then I have A over here. Right? This is by the AA test. But if you notice, they're asking me ECF. So in EFC, I should just interchange these two vertices. So I can say triangle ECF is therefore similar to triangle ABD by the AA test. So sometimes you might conclude on different order of vertices, but later on you can definitely arrange the vertices to match what you are being asked to prove. So this is how I solved this particular question. Again, pausing for a few seconds before I move on to my next question. Moving on to the next question. Let us now consider this question. Through the midpoint M of the side CD, so M is the midpoint of CD. Let us quickly mark it. M is the midpoint of CD. Of a parallelogram ABCD. So this is a parallelogram ABCD. So the opposite sides are going to be parallel. Let us mark that as well. Line BM is drawn intersecting AC at L. So this point here is L. And AD produced at E. Prove that EL is twice of BL. So let us shade the side that we have to prove. We have to prove that EL is twice of BL. Right? So now if I want to prove that EL is twice of BL, there is one triangle that comes to my mind which will help me prove this particular point. So consider the triangle ALE, okay, and triangle BLC. So EL and BL are the two sides of this triangle, which means that if I can prove that these two triangles are similar, something might come out of this particular situation, right? So let's consider, I will say consider triangle ALE and triangle BCL for similarity. Now let us see if these two triangles are similar. We know that vertically opposite angles are equal, so that's one equal part. And I also know that AE is parallel to BC, so I can use the alternate interior angles, right? These two angles are equal to each other. So by A test, these two triangles are similar. So I can say angle ALE is equal to angle CLB because these are vertically opposite angles, and also angle EAL is equal to angle BCL because these are alternate interior angles, and also AE is parallel to BC, right? And therefore I can say that triangle AEL is similar to triangle CBL because of the AA test. Now writing the ratios, I get AE divided by CB is equal to EL divided by BL, which is equal to AL divided by CL, and this is because of corresponding sides of similar triangles. So now I'm really glad that I have got the ratio EL by BL. I think I want to prove EL is twice of BL. So somehow I have got a relation between EL and BL. However, I have no clue of the terms AE by CB, and I have no clue of AL by CL as well. So now I have to think of a way by which I can prove a relation between them. I am going to pause here for a minute. I will let you see if there is a method by which I can get some relation between the two unknown quantities, right? So if I can find AE by CB or AL by CL, I think then I will be able to find EL by BL. So let me pause for a minute, see if you can find that out. Okay, so this is how I am going to think about this problem. There is a good chance that I might be able to find the ratio between AE and CB. Okay, so let's see how we can go about this. First of all, I know that AE is composed of two parts. One part is AD and the other part is DE. I know that the length of AD is equal to the length of CB, and let both of them be X. So I know that let AD be equal to BC, be equal to X. The reason is these are the opposite sides of parallelogram ABCD, right? Now, is there a way to prove that AD is also X? Because if I prove that AD is X, then AE will become 2X, and therefore the ratio of AL by CL will become, or rather the ratio of AE by CB will become 2/1, and then I can prove EL is twice of BL. So what I'm saying is, if you can prove that this ratio is 2, then EL by BL will become 2, and therefore EL will be twice of BL by cross multiplication. So now let's consider these two triangles for congruency. So let's consider the following triangles for congruency. If I take triangle EDM and triangle BCM, let's see if I can prove congruency in them. So first of all, I know that the lengths DM and CM are equal, right? So I know that, so okay, let me write that here. Consider triangle TEM and triangle BCM for congruence. I know that DM is equal to CM because it's given that M is the midpoint. I can say that these two are vertically opposite angles, right? So angle DME is equal to angle CMB because these are vertically opposite angles. And also angle DEM is equal to CBM. Angle DEM is equal to angle CBM because these are alternate interior angles, right? And again because D is parallel to BC. So therefore by angle side test, I have a dot, I have an arc, I have double sticks, a dot, an arc and double stick. So I can say that triangle DEM is congruent to triangle. So DEM, E corresponds to B, then M corresponds to M, and I have C over here. And this is because of the AAS test. This implies that CB, or rather DE, will be equal to CB because of CP/CTC, and therefore CB is equal to X, which means DE is also going to be equal to X. So I can say that this implies AE is 2X, or rather AE is equal to twice of CB because X is CB, and therefore AE upon CB becomes equal to 2. Right? So what I did was, first, because ABCD is a parallelogram, I knew that AD and BC are equal to each other. So I took those sides as X. Again, by the AS test of congruency, I proved that CB and DE are equal to each other. So again, because CB was equal to X, the length of DE is also equal to X, right? I was able to conclude that, which meant that AE was 2X. So AE by CB is 2. And therefore, I can say that because AE by CB is 2, 2 is equal to EL upon BL, which means EL is twice of BL, and hence proved. So if I were to recap this particular problem, first I took the triangles for similarity, right? So which triangles did I pick? I picked triangle ALE and CLB for similarity, for the only reason that EL and BL were the two sides of that particular triangle. And then I used congruency to prove that these two triangles were congruent to each other. The shaded triangles were congruent, and using CSST and CPCTC, I was able to show this particular proof. So let me pause for a minute or two, take a careful look at this particular solution, and then we will move on to our next question. Moving on to the next question. Let's take a look at this particular question. In this figure, it is given that triangle ABE is congruent to triangle ACD. You have to prove that triangle ADE and triangle ABC are similar. So now, because these two triangles are similar, it is given that triangle ABE is congruent to triangle ACD, and therefore I can conclude many things from this. I can conclude that the length AB is equal to AC. So AB equal to AC means this complete triangle is isosceles, right? It means that angle B, the whole of angle B is equal to the whole of angle C. That is one conclusion. So AB equals AC implies angle ABC is equal to angle ACB, because these are the base angles of isosceles triangle. Similarly, I can also conclude that the length AE is equal to the length AD. So AE is also equal to AD, and this implies, so if the length AE is equal to AD, let us shade it. If AD is equal to AE, then I can again say that triangle AD is also isosceles, which means angle ADE is equal to angle AED. Again, base angles of isosceles triangle, right? So these so basically we have two isosceles triangles. AD is one isosceles triangle. So this implies triangle ABC is isosceles. ABC is isosceles, as well as triangle ADE. Triangle ADE is also isosceles. Now I know that in triangle ABC, angle A plus angle B plus angle C should be equal to 180 degree, because this is the angle sum property of a triangle. And similarly, angle A plus angle ADE plus angle AED should also be equal to 180 degree. Again, because these are angles of a triangle. So this implies angle A plus, now angle B and angle C are equal, so this is twice of angle B, is equal to angle A plus. These two angles are also equal to each other. That is what we concluded, right? Because these are the base angles of the isosceles triangle. So 2 times angle AD should also be written here. Now angle A and angle A cancels. Now why did I equate these two? Because both these LHS are equal to 180 degrees. So if they both are equal to 180, then their base angles have to be, or rather their angle, if both the left hand sides are equal to 180, then the left hand side should be equal to each other. So from this, angle A cancels, and I'm left with 2 angle B is equal to 2 angle AD. And now 2 cancels, which means angle B, that is the whole of this angle B, is equal to angle ADE, right? So similarly, I can, say that angles, because these two angles are equal to each other, as angle B, angle ABC and angle AD are equal to each other. So I can make a note of that. As angle ABEC is equal to angle ADE, I can say that DE is parallel to BC because of corresponding angle test. The corresponding angles are equal, right? And therefore the lines have to be parallel, which means that now these two lines are parallel. And now I can use the AA test for similarity. So if I say consider triangle ADE and triangle ABC for similarity, I know that angle A is equal to angle A because that is the common angle. That angle exists in both the triangles. And also angle ADE is equal to angle ABC, that was already proven, right? So I can mark this result as 1 and I can say from 1. And therefore by AA test, I can say that triangle ADE is similar to triangle ABC, and this is what we wanted to prove and hence proved. So using congruency, I first found out that there are two isosceles triangles in this particular diagram and their base angles had to be equal. And then I was able to show that angle B and angle D, the yellow angles that are shaded over here, are actually equal to each other. And then using angle A as the common angle, I was able to prove similarity. So let me again pause for a minute before I move on to the next one. Moving on to the next question. Let's take a look at this question. ABC is an isosceles triangle with AB equal to AC. So let us mark those sides. It's given that the side AB is equal to side AC. So if AB is equal to AC, it means that these are the base angles of the isosceles triangle. And D is a point on AC such that BC square is equal to AC into CD. So when I say BC square is equal to AC into CD, I can rewrite this as BC into BC is equal to AC multiplied by CD. I have to prove that BD, the length BD, I have to prove that BD is equal to BC. So what this means is I have to somehow show that these two angles, that is angle D here, I have to prove that this angle is equal to angle C. So basically the angles which are shaded right now in yellow, I have to show that these two angles are equal to each other, right? It is not given right now, by the way. Right now what is given is angle B is equal to angle C. But if I can prove that the angle D, angle BDC is equal to angle BCD, that would mean that BC and BD are equal sides, again because of the property of isosceles triangle. So now we have to think, how can we get angle D and angle C equal to each other? So now if I rearrange what is given to me, it's given that BC into BC. So let me do one thing. Let me rewrite this as BC upon AC is equal to CD upon BC. Okay. And what I'm going to now do is I am going to draw two triangles separately. Let us see which triangles I should be drawing. BC upon AC, okay, is equal to CD upon BC. So I'm going to draw the complete triangle ABC and triangle BDC, and let's see if something comes out of that, because these are the sides of those two triangles. So let me draw them separately. So I have drawn these two triangles separately, again keeping the alignment similar to the original figure. It's given that BC, so I have shaded it with the green line. So BC is shaded with the red line. So consider this particular part to be the sides of triangle BCD. Okay. So BC belongs to triangle BCD. So BC is the red part. So BC divided by AC. So this is the ratio of these two sides, is equal to CD, that's the green line, CD upon BC. So this is the ratio of the second side, right? So what I can do is I see that the ratio of two sides is equal to each other, and I also notice that angle C is equal to angle C because this is the common angle in both the triangles, and therefore I can use the Sas test for similarity. So what I'm trying to say here is consider triangle BCD and triangle ABC for similarity. We know that BC divided by, so BC is the red line here. This is the first side that I am shading right now. That is the numerator. BC divided by AC. So that's the first side of the second triangle. So BC upon AC is equal to CD upon BC. Those are the second sides that are shown here. This is already given to me in the question, and angle C is equal to angle C because this is the common angle. And because this is the common angle and two sides are in proportion, I can say that triangle BCD is similar to triangle. So now let's take the right ratio. So C corresponds to C. C is the second letter here. If I walk on the red line, I reach B, right? So here if I walk on the red line, I reach A. So the point B corresponds to A here, and the third vertex will therefore be B, right? So again, let me repeat. I started with the common vertex. The common vertex was C in both cases. So the common vertex was basically the angle C or the vertex C. And from C in triangle BCD, I walk on the red line, I reached vertex B. And if I walk on the red line in the first triangle, that is in triangle ABC, if I walk on the red line, I reach A. That means the vertex B corresponds to vertex A in this triangle. And that is why if B is written as the first vertex, then A is written as the first vertex. And this is by the AA test. I'm sorry, SAS test. Excuse me, the SAS test was used in this particular solution. So this is by the SAS test. Now because these are similar by the SAS test, let us now see what can be done. We can say that from this particular pair of triangles, the angle D in triangle BDC, so I can say that angle BDC, that is the angle that I am shading right now in the brown color, this particular angle BDC is going to be equal to, so this point D actually corresponds to B, is equal to angle BDC will be equal to angle ABC because of corresponding angles of similar triangles. That means these two angles, so angle D corresponds to angle B, these two angles are equal to each other, right? So now in this diagram, what I'm going to do is, I'm going to say that angle ABC is this yellow angle that is equal to angle BDC, which is this angle here that I just shaded now. So according to similarity, these two angles are equal to each other. But isn't angle B equal to angle C, right? So I know that angle ABC is equal to angle ACB. That's because AB was equal to AC. And therefore, I can say that using transitivity property, because BDC is equal to ABC, but ABC is equal to ACB, I can say that angle BDC equals angle ACB. That means angle BDC, this particular angle, is equal to angle ACB, that is this particular angle. And these are now the base angles of an isosceles triangle, which implies that side BD is going to be equal to BC because base angles are equal. Base angles of the triangle are equal, and hence this means that this is an isosceles triangle. So this is how I prove BD equals BC. So in this particular question, BC square equals AC into CD was given. Using that, so let's mark some important points here. BC square equals AC into CD was given. From that, I reached this particular ratio, right? And this ratio gave me the hint regarding the triangles that I should be choosing for proving similarity. So I chose these two triangles for similarity, and I was able to use the SAS test. So the ratio of sides was equal, and I noticed that I had a common angle. So I was able to prove the pairs of triangles to be similar now by the SAS test. And then using the concept of corresponding angles of similar triangles as well as transitivity, I was able to prove angle BDC equals angle ACB. So because the base angles of triangle BDC are equal, I can say that the length BD is equal to BC. So this is how I went about this particular solution. We conclude our segment here today. So I will pause for a minute, and this marks the end of today's session. concluding today's session here.